Hello everyone and welcome back to our channel Zenith Academy Online. I am Shahana and today we are on our second session of trigonometry for class 10. Now, in our previous session, we have learned two sets of relations for trigonometric identities. One was the reciprocal relation between the trigonometric ratios and the other one was the square relations. Now, in this video, we'll be doing trigonometric ratios for complementary angles. So, let's start. Now, trigonometric ratios of complementary angles. What is complementary angle? Two angles which the sum of which is 90 degrees are said to be complementary angles. This we know. Now, for right angle triangle, how do we define complementary angles? This is our 90-degree angle. This is the right angle triangle, right angled at B. Now, for trigonometry, we took the reference for this angle. In reference of this angle, we defined the sides, different sides of trigonometric ratios. So this was our theta. Now, if I see for this theta, I have this perpendicular. This is BC is the base and AC is the hypotenuse. If I invert this triangle, then I have this angle also. So, for this angle, let's say this angle is alpha. So, for this angle, what will be a perpendicular? BC will be a perpendicular. Our hypotenuse will remain same, AC, and our base will change to AB. Now, since this is a right angle triangle and all angles, that is the three angles, so sum of three angles of a triangle we know is equal to 180 degrees. So, if this one angle is given to us as 90 degree, the sum of other two is would definitely be 90 degrees. So this implies alpha plus theta is equals to 90 degrees, and hence these both angles are complementary angles. Now, what is the significance of this complementary angle in trigonometric ratios? See, now first see, in reference to theta, we learned what is sine theta? Sine theta is perpendicular upon hypotenuse. So, here a perpendicular is AB and our hypotenuse is AC. So, this is AB upon AC. Now, what is cos theta? It is base upon hypotenuse. So, what is base? BC upon AC. And now our third basic function, that was the tangent theta or tan theta, which is perpendicular upon base. So AB upon BC. These were the three basic functions we learned. Now, these three functions are with respect to theta. We can write these three basic functions with respect to alpha also. So, in the same way, what will be for it for alpha? Sine alpha is perpendicular upon hypotenuse, and with reference to alpha, what is a perpendicular? BC, and hypotenuse is same, AC. Now, what is cos alpha? Cos alpha, with reference to alpha, base upon our hypotenuse is cos alpha. So, with reference to alpha, our base is AB and our hypotenuse is AC. So, this will be AB upon AC. And tan alpha is perpendicular upon base. So now here a perpendicular is BC and base is what? AB. So BC upon AB. See clearly, sine theta is equal to AB upon AC. Here cos alpha is equals to AB upon AC. Right? Cos theta is BC upon AC. and here BC upon AC is equal to sine alpha. So if we draw reference from this, what we will get, sine theta, which is equal to AB upon AC, is also equal to cos alpha. These both are equal to AB upon AC. This is why we took sine theta is equals to cos alpha. Now, cos theta is equals to sine alpha, which is equal to BC upon AC. And our last ratio, see, tan theta is equal to AB upon BC and tan alpha is BC upon AB. So how can we write this? Tan theta is equal to AB upon BC, and this is the reciprocal. So we can write this as 1 upon tan alpha. Tan theta will be equal to 1 upon tan alpha, because this is just the reverse, AB upon BC, and tan alpha is equal to BC upon AB. So now we know that theta plus alpha was equal to 90 degree because they both are complementary angles. So what we can write, alpha is equals to 90 minus theta. This way we can write this alpha. So if we see this first equation, sine theta equal to, I can write cos 90 minus theta. For this second, cos theta is equals to sine alpha. Cos theta is equal to sine alpha. So alpha we can write it as 90 minus theta. Again, so for sine theta we can write cos 90 minus theta, and for cos theta we can write sine 90 minus theta. Same way, now tan theta is equals to 1 upon tan alpha. So tan theta is equals to 1 upon tan alpha. Now for tan alpha, 1 upon tan alpha is also equal to cot alpha. We know cot is the reciprocal of tan. So 1 upon tan alpha can be written as cot alpha also. So tan theta is equals to cot, and instead of alpha we can write 90 minus theta. So tan theta is equals to cot 90 minus theta. This is how we take the ratios for complementary angles. Sine 90 minus A. Here the angle is taken, instead of theta we have taken as the angle name as A. So sine 90 degree minus A will be equal to cos A. Cos 90 minus A is equals to sine A. Tan 90 minus A equal to cot A. Since for sine and cos the reverse is also possible, same way for tan 90 minus A is equals to cot A. So for the reverse is also possible. So cot 90 minus A is equals to tan A. Now what are our remaining two ratios? Sec and cosec. So we can make the relation between sec and cosec now. Sec 90 minus A is equals to cosec A, and then the same way cosec 90 minus A is equals to sec A. So these are our 6 identities. We have been given the figures 22 and 68, and if we total up 22 and 68, they will come up to 90 degrees. So 22 plus 68 is equals to 90 degrees, and hence they are complementary angles. So cos 22 degrees, either write cos in terms of sine or take sine in terms of cos. So I take sine in terms of cos. So cos, how can I write this? Cos 90 minus 68. This is theta. So sine theta is equals to cos 90 minus theta. So cos 22 degrees upon, what is 90 minus 68? 22. Since they were complementary angles, so cos 22 upon cos 22, this gets cancelled and we get the answer as 1. Cos 55 degrees upon sin 35 degrees plus cot 35 degrees upon tan 55 degrees. Now see, these two angles 55 degree and 35 degree, they are complementary angles because their sum is 90 degrees. 35 and 55, here also they are 90 degrees. Cos and sin and tan and cot are related complementary angles through. So cos 55 degrees and instead of sin 35 degrees I can write it as cos 90 minus theta, that is 90 minus 35, and here cot 35 degrees upon tan, so I can write this as cot 90 minus theta, that is cot 90 minus 55. So if we solve it, cos 55 upon cos 55, 90 minus 35 will give us 55 plus cot 35 upon cot 90 minus 55 will give us 35. So cot 35. Now they both will get cancelled. We get what? 1 plus 1, which is equal to 2 as the answer. So this is how the ratio for trigonometric ratios for complementary angles work. Now let's start with the practice questions. Sin 42 degrees sec 48 degrees plus cos 42 degrees into cosec 48 degrees should be equal to 2. This is our LHS. Now we need to evaluate and our answer should be equal to 2. 42 and 48. They both are complementary because 42 plus 48 is equals to 90 degrees. Sin and cos are related. Sec and cosec are related. So in either of the term we need to change. So for sin, let's say I keep this as sin 42 degrees into, for sec 48 degrees, if I write sec, we know is the reciprocal of cos, so I can write this as cos 48 degrees, right, plus cos 42 degrees, cosec is sin, so I can write this as 1 upon sin 48 degrees, right. Now for cos 48, I can write this in terms of sin, so sin 42 degrees into 1 upon cos 48 can be written as sin 90 minus 48, and for cos into 1 upon sin we can write in terms of cos as cos 90 minus 48. So now it's very easy. Sin 42 degrees upon, what is sin 90 minus 48? Sin 42 degrees. Sin 42 degrees plus cos 42 degrees upon, what is cos 90 minus 48? 42. So this is cos 42. Now it's simple. This is 1, this is 1. So 1 plus 1 will give us 2. And hence our answer. Let's move on to the next question. Sin A cos A minus sin A into cos 90 minus A cos A upon sec 90 minus A minus cos A sin 90 minus A sin A upon cosec 90 minus A is equals to 0. Now I know This is sounding a little bit complicated, but it is actually very easy. Just follow the steps. See, sin A cos A is given minus, now sin A, what is cos 90 minus A? It is also sin A. So let's solve it. Sin A and this cos 90 minus A is also sin A into cos A upon, what is sec 90 minus A? Sec 90 minus A is equals to cosec A. Now, similarly here, cos A is given, what is sin 90 minus A? Cos A into sin A upon, what is cosec 90 minus A? Sec A. Now, sin A cos A. If we see clearly, if we take all these terms in terms of cos and sin, it will be easier to solve. So it's better to convert cosec and sec into also sin and in terms of sin and cos. So now here it will be sin square A cos A upon cosec A is what? 1 upon sin A. Cosec is the reciprocal of sin, and we can write this as cos square A into sin A upon, what is sec A? The reciprocal of cos. So 1 upon cos A. Now, in denominator we have a fraction. So sin A will go to the numerator and here the cos A will go to the numerator. So what we will get? Sin A cos A minus sin cube A cos A, because we shifted this to the numerator, minus cos cube A, cos A into cos square A into sin A. So now sin A cos A minus sin cube A cos A and minus cos cube A sin A. So let's take common sin A cos A. We can take common sin A cos A, this term. So what it will be? 1. It is taken common, so this is 1 minus, this is sin, here what it will remain? For sin A cos A, if we divide, see, I show it to you here. Sin cube A cos A, when taken common with sin A cos A, so we divide it. So what will remain? Cos A gets cancelled. Sin A, and this will here remain sin square A, because it was 3 times sin and 1 sin A get cancelled. So remaining will be sin square A. So what we get here? Sin square A, and in the similar manner for cos cube A, see, cos cube A into sin A upon sin A cos A. So what will be the remainder? Sin A gets cancelled. Cos A is 1. This is 3 times cos A is multiplied. So 1 cos A gets cancelled. So what will be the remaining? Cos square A. So here we will get cos square A. Now if we see clearly, we know sin square A plus cos square A is equals to 1. But here it is minus. So both the terms are in minus. Minus sin square A and minus cos square A. We can take minus common and make it plus. See, sin A cos A 1. If I take minus common here, so what will be in the bracket? Sin square A This is positive sine square A and positive cos square A. This is why, this is so because when we open the bracket, minus plus gets minus, which is minus sine square A, and minus plus is again minus, which is minus cos square A. So this is how we take the common. Now this we know, sine square A plus cos square A is equals to 1. So sine A cos A 1 minus, this whole term is equal to 1. Now what is 1 minus 1? Equal to 0. So sine A cos A into 0, and anything multiplied by 0 will give us the answer as 0, and hence this is what our RHS is. Let's move on to our next question. For triangle ABC, show that our first part is sine A plus B by 2 is equals to cos C by 2. Now it is saying for a triangle ABC. Now see, this is a triangle ABC. This is a triangle ABC and we have got three angles, angle A, angle B and angle C. Now angle A plus angle B plus angle C is equal to what? 180 degrees. The sum of the angle of a triangle is always 180 degree. Now it is saying sine A, what we need to prove is sine A plus B by 2 is equals to cos C by 2. If we can, how can we write this? Angle A plus angle B is equals to 180 minus angle C. The sum of these two angles will be equal to 180 minus the third angle, 180 minus angle C. This we can write. So let's see how can we use this here. This is our LHS. We are taking LHS. So sine A plus B by 2. Now how can we write sine A plus B by 2? A plus B, this angle A plus B is equals to 180 minus angle C. So 180 minus C divided by 2. So sine, now split these two terms. So 180 by 2 minus C by 2. Sine 180 by 2 minus C by 2. Now what is 180 by 2? 2 ones are 90s are. This is 90 degrees. So what we get here? Sine 90 degrees minus C by 2. Now we know sine 90 minus A is equals to cos A. So what will be sine 90 minus C by 2? Cos C by 2. Cos C by 2 is our answer. This is because sine 90 minus A is equal to cos A. Now see, students, please note that this reason, that is the identity which I have used or the ratio which I have used, we always need to mention each and every ratio or the identity we use in every step we take. See, I am teaching you, so I don't write each and every reason, but you need to write this in exam, so that the marks, so that you can score full marks and your marks did not get cut just because you did not mention the reason. Now our first part is done. What our second part is says, tan B plus C by 2 is equals to cot A by 2. Sine and cos are related, complementary angles, and tan and cot are related. We can do the same method which we have done in this. Tan B plus C by 2. For triangle ABC, we knew A plus B plus C was equal to 180 degrees and we wrote A plus B is equals to 180 minus C. In the similar way, we can write B plus C is equals to 180 minus A. So tan B plus C by 2 will be what? Tan 180 minus a. For b plus c, we can write 180 minus a upon 2. So, 10, 180 by 2, when we split this, 180 by 2 is what? 90. And this will be remaining a by 2. Now it is easy. What is tan 90 minus a? Cot a. So, our answer is equals to cot a by 2. And remember to write the property. So, this is what we used. Tan 90 minus a is equals to cot a. This is what our RHS is. So, this was all for our today's session. We have completed 2 videos, and in our other video, we'll be doing some more sums relating to this topic. So, if you want to gain more conceptual knowledge about the topic, please stay tuned. And in our other videos, we have covered trigonometric tables as well. So, keep watching, keep learning, and if you haven't yet subscribed, please do subscribe.